Okay, so for those of you having trouble figuring out how to set up ratios and things of that nature, this is designed to help you do that. So when we have two similar figures, in this case, I'm going to give you the statement that says triangle ABC is similar to triangle. And we know these are similar because they have two sets of corresponding angles that are congruent. That means that's the angle-angle similarity theorem. So it makes sure, so it does mean that these are similar. So we're going to go ahead and write a ratio similarity statement. So angle A is the unmarked angle. That should match up with E, the other unmarked angle. Angle B is one tick mark, and that's going to match up with angle F. And angle G is marked with 2 as well as angle C, so it's going to go E, F, G. They don't always go in alphabetical order. You have to double check that everything matches up. This is just a coincidence. So those are equal. I'm asking you to find the value of the segment, the length of the segment BA or AB. So we want to know what this is. All right, so all we're going to do is set up ratios of corresponding sides. So AB is what we want. We're going to start with that. And according to this statement, AB matches up with EF. So EF is going to be 9. And then similarly, we have 7 over here, so we're going to put a 7. That's BC. And BC is going from 1 tick mark to 2 tick marks, so we find that over here. It's going to be happening at the bottom, which is 14. And all we're going to do now is cross multiply 9 times 7. And we're going to cross multiply 14 times x. And we're going to get 63 equals 14x. All right. And then what we're going to do at that point is we are going to just get x by itself. We're going to divide both sides by 14. And we're going to come up with a final answer of 63 divided by 14, which is 4.5. So that's how you find that. Now another one that gives people difficulties would be a problem that looks like this. If I do another example, this would be when two triangles overlap each other. And if I knew these sides were parallel, that's going to play a part. We'll call that A, B, C, D, E. There are two triangles here. These are parallel lines, so what that means is that, if we extended these as transversals, these would be corresponding angles, and they'd be congruent. And the angle A for both would be the same, so that's congruent. And angle B and C are also corresponding angles, so those are congruent. So by angle-angle theorem, these are similar. But anyway, I'm putting some numbers in there. I'm putting a 4, a 5, we'll put a 6 and an x, and I want to find out what that x spot is, so BC. So the common mistake is that most people will put 4 divided by 5 equals 6 divided by 8, just like we did above. That's wrong because those aren't the corresponding triangles. The corresponding triangles are this small one, A, E, B, which we know are 4 and 6, and the other one is this bigger one, which is A, D, C. Now the left side, most people don't screw up. It's from A to D. It's not 5, it's 4 plus 5. It's the addition of those two segments. So it's 4 plus 5, which is 9. That segment's 9 units. This is the one a lot of people screw up. It's 6 and x. You don't want to put x. It's the whole length. Just like we did here, we're just going to add 6 plus x. And there's nothing to do there. It's just 6 plus x. So at that point, what we're going to do is we're going to go ahead and write a proportion, just like we did in the last problem. The 4 goes with the 9, and the 6 goes over the 6 plus x. From this point on, all we're going to do is cross multiply. 9 times 6 is 54. 4 times 6 is 24. 4 times x is 4x. And subtract 24 from both sides. 54 minus 24 is 30. And to get rid of that 4, you're simply going to divide both sides by 4, and you're going to get x equals 7.5. And you're done. And one more application that we'll save for another time.